Good morning, everybody. We're going to give everybody coming into the webinar just a few more minutes before we begin. We'll start here in about 30 seconds or so. Good morning. Welcome to our webinar today on HVAC predictive maintenance and how you can leverage the Cool automation software for handling that more effectively and remotely. So my name is Ben Shipley. I'm VP over North American Sales. Wonderful to have all of you attending today. We also have Kevin Ward, our Customer Success Manager in North America, on the call, who will also be presenting, as well as David Diaz-Perez, our Technical Sales Manager. Before we begin going into the presentation properly, I would like to take an opportunity to briefly introduce our company. I'm not going to spend a lot of time on that, as well as give a very high-level overview of our hardware that enables what you're going to be seeing here in a few minutes from our software. Cool Automation has been around since 2009. We were established with creating a comprehensive integration as well as remote management solution for the VRF and mini split space. We are based in Tel Aviv, Israel. However, we do have offices in North America in the United States. Understanding the topology of how this works, I think, is important for orienting you to, again, leveraging the capabilities in the software. We install an edge device. Typically, this is the Cool Master, and that is installed in the space itself. That natively communicates with a VRF system, no matter the manufacturer. So whether we're talking Daikin, Mitsubishi, LG, Samsung, whoever it might be, that interfaces directly into the outdoor condensing unit. Once it is connected to the outdoor condensing unit, it will do a discovery on all the units within the system, populate them into a touchscreen interface, allowing you to handle it locally. But most importantly, through an Ethernet connection, it connects over the internet into the Cool Automation Cloud. Once it's in the Cool Automation Cloud, you have several options for how you can leverage the capabilities of the device, as well as the data available through the device, as you can see outlined on the left-hand side of the slide. This includes our predictive maintenance capability, which again, we'll be going in here in just a minute, talking about in more detail. That allows you to do remote diagnostics, etc. We also have the capability to do remote control, set point modifications, scheduling changes. We have a management capability that allows for globalized changes, as well as globalized rules and interlocking features. And then last, and we won't be talking about this except for right now today, we also have power distribution capabilities. So through this device, you're able to get all of that data, all that capability. We'd like to say that this device really fills 5 positions in your control scheme. It can act as a central controller. It can act as a backnet integration device. It acts as Wi-Fi access. It acts as a service tool. And then lastly, it acts as a power distribution option. So this is what facilitates moving that data up to the cloud. But the emphasis today in this presentation is to talk about the cloud itself. So I'm going to take the opportunity now to turn the time over to Kevin Ward, who will take you through the software, a scenario, and how this can be applied in real world circumstances. So Kevin, I'm going to turn the time over to you.
Thank you, Ben. Thank you everybody for joining us today. My name is Kevin Ward. I'm the Customer Success Manager for North America. So ensuring your success with our software packages and how to leverage these solutions in order to better manage your space and provide preventative maintenance solutions for enhanced support. With our service app, when you first log in, there's a dashboard overview giving you a quick snapshot of the status of your sites. And today we'll be walking through an example for a hotel in Los Angeles, California, where we had a case where the set points weren't being satisfied. There was a complaint coming in from the hotel. And I'm going to walk you through the steps of how to leverage this software in order to diagnose the issue and talk about ways of catching these issues before they happen. So in this hotel, facility manager noticed the corridors are a little warm and they call their service provider. Service provider can log in, check any active alerts that were happening for our hotel. This call came in on February 11th. So we'll make sure we select that range for our active alerts. And we can see that there was a U0 error code. By clicking on this, you get a description. The U0 error code is translated as a shortage of refrigerant. So we know that there's absolutely an issue on February 11th. You can see this affected all of system 3. So now let's utilize the diagnostics piece of our software in order to try to identify exactly what happened here. So we'll navigate to the unit diagnostics tab. We'll select system 3. We'll pick our second floor corridor. We'll make sure to select the active dates where that error occurred. You can see some of the points coming in already. But just to give you a good look at a simple way to identify the issue in the space, you can overlay the room temp and the set point. Ultimately, it is pretty clear that there is an issue with this system. With the set point set to 68 degrees, the system is in cooling, but is only 74 degrees in the room. So from a diagnostic perspective, we want to select certain parameters to identify why this system isn't performing. And with an indoor unit, it is fairly simple. My main 3 parameters that I'd recommend checking are the valve opening for that indoor unit, the gas temperature leaving the coil, and the liquid temperature entering the coil. So as we select these parameters and they move to our graph, we can see this valve position skews the way the data is presented. And luckily we have a dual axis system where we can move this scale to the right y-axis so that everything is presented a little bit more cleanly on the graph for you. So we also want to select our gas and liquid temperatures here. And right away we can tell the system is not able to satisfy the set point for this corridor. You can see that there are about a 20-degree delta from the liquid coming in versus a 65-degree temperature leaving the coil. That seems okay, but the valve position at 2000 is fully open. So this fan coil is giving it everything it's got, and it's unable to satisfy the space. And this typically indicates a shortage of refrigerant or a lack of capacity for this fan coil to satisfy that set point. So everything's operating. A VRF system is very robust and will try to continue to operate even as that refrigerant gets low. But ultimately, the U0 error code the system got to a critical point where it actually shut down and triggered that site to call for a support call, or to call their service provider in order to investigate the issue with the site. With our software, at this point, I'm going to show you how you could leverage the preventative maintenance side in order to have caught this issue before the phone call happened. So we do have anomaly rules, which is going to be your watchdog for your system. These are custom alerts that will actively monitor those diagnostic parameters and trigger an alert based off of a custom description. In this case, we had a low refrigerant, potential leak in the system, and we have an anomaly rule set for just that. So our system now with this custom anomaly will actively monitor each of your indoor units for the valve position, the room temp and the set point being satisfied, and the delta between the gas and liquid temperatures. So how quickly is that refrigerant evaporating through that coil? If the room temp is not satisfied and the valve is wide open, this at least indicates a possible case of low refrigerant. And let's see how this looks when it's triggered at this site. So in our alert log for the system, we can see that the U0 error code where the system actually faulted out occurred on February 11th. If we go back, we can see that there was an anomaly rule that triggered over a week prior to the system faulting out. So simply double clicking this anomaly rule will bring you back to the unit diagnostics section with your parameters preloaded with that anomaly overlaid onto the graph here. So the room temp, the set temp, liquid and gas, and the valve position. Again, adjusting this so that everything fits nicely on the graph. We can see here that each of those different conditions have been satisfied. We can see a 30-degree delta across the coil, a 5-degree difference between the set point and the room temp, and that valve position wide open. So leveraging the anomaly rules would have allowed us to catch this system error, the low refrigerant, a week prior to the system actually failing on its own. At this point, I'd also like to talk about set point management. Overall, the majority of our service calls are going to be, it feels warm or it's too cold if the system's in heating. Essentially, the set point is not satisfied. The system is not operating as it should for your customers. Another feature of our app will be a simplified report section where you can quickly analyze the performance of your site. Here you can see a breakdown of the overall cooling and heating hours, power consumption of your system, how hard your system is working with the system diversity, how often your systems are actually calling for heating or cooling, and as I mentioned, set point maintenance. This will give you a snapshot view of how well your system is actually satisfying set point in this at your site. With the full graph, the full bar graph here, you can easily tell which fan coils are satisfying the space and how often they're out of range. This fan coil is working exceptionally well, satisfying it 98% of the time. It's only out of range 2%. Whereas the next group of fan coils here are never satisfying the space, indicating a potential issue or potentially a set point that is unrealistic for that fan coil to actually satisfy. Perhaps they're set to 68, but the system's only able to hold 72. Or in heating mode, if they're set to 90, it's too cold outside and it's unrealistic for the set point to actually ever be satisfied by the system. So let me show you how to leverage the control of your space using some wired control restrictions. In order to gain better control of your space, our service app also gives you the capability of limiting the cooling and heating set points from the wired controller. In your hotel, for example, in the corridors, if we just want those set points to always be within 72 and 78 degrees Fahrenheit, 72 to 80. And in heating, 90 is unrealistic, so we'll leave that as a 78-degree upper limit. If any changes are made at the wired or the local level from the wired remote controller, our software will actually restrict it back to 72, or if it's above 80, it will bring it back to 80 as well. It will not allow for the actual person on site to turn that unit off from the controller. If these are selected, you cannot change the mode with this selected, or you can completely limit any set point change from the local level using this option here. This can be scheduled as well, but ultimately this set point restrictions will give you more control of your space, optimizing efficiency, allowing your system to be satisfied and more comfortable overall. At this point, I'd like to turn this presentation back over to Ben Shipley, who can help summarize everything we've covered today and help with the wrap up as well.
Thank you, Kevin. So to summarize our capabilities in the cloud, I wanted to highlight a few of the key capabilities within the software itself. So as Kevin has gone through to distill this down into the fundamentals, I touched on the beginning of the presentation, but I want to emphasize it again that all this data that you've seen Kevin demonstrate is available for all the VRF manufacturers. So you're not limited to just a Daikin system. You can look at this with whoever's out there, Fujitsu, Mitsubishi, as I've touched on, Samsung, whoever that might be. We are capable and able to provide that same type of ability through all of those. In addition to that, we have a robust set of anomaly rules. You have the ability to distill up the error codes coming in from the system, but you also have the flexibility and capability to be much more refined by either leveraging our library of rules that we've created or creating your own custom set of rules. And the idea and hope that you're getting out ahead of these problems before they become catastrophic, and ideally before they're even detected by the people on site. The software retains the data for up to 12 months. So this means that not only are you troubleshooting in the moment, but our software can learn your system. And by learning your system, it's going to be able to provide much deeper analysis on how it's performing over a longer period of time, as was highlighted in the report dashboard. These reports, very easy and capable to use. You can leverage the unit reports, the system reports, as Kevin had outlined, and the long-term analytics reports that go into the maintenance and the overall performance of the system. And we track all the history. So all the errors coming up from the system, all the anomalies that might have been generated, all the changes that might have been initiated, whether through the software, the hardware, or through a user on site, that's all trended and tracked. So you can access that data very quickly as well. And then we have numerous capabilities in limiting the access for the users on site to ensure that you are preserving optimal run on your equipment, and ideally also maximizing your energy savings over the long haul. So lots of capabilities, and really today we've just delved into the system diagnostics portion of it, but in future webinars we'll touch deeper into the reports dashboard that you saw there, as well as other capabilities that we have through our management software on top of that. So what does this equate to? So these are the advantages. What are the actual quantifiable savings that come from leveraging these capabilities? So savings that we've seen, that we've been working with our customers to understand the generated savings and advantages that they've been seeing by using the system are significant, as you can see here in this slide. By using these tools and leveraging them completely, you're able to reduce down the system downtime again, dramatically. You could see 50% reduction on that. And that comes through, again, the earlier detection, right? You have the ability to remotely look at this on top of everything else. You also have the proactive alerting capabilities that come through the anomaly rules. What's that equate to? Less time that your system is down. And that goes right into preserving the lifespan of your system as well. So you're able to prolong that system by years because you're running it better, because you're servicing it much more closely, and you're avoiding any catastrophic issues, which, as we all know, when a catastrophe happens, it not only is something that has to be addressed immediately, but it has an impact on the health of the equipment over the long haul as well. By being optimized here, and we're going to isolate this conversation today, just the optimization of the system, that equates as well to energy savings. Our customers are seeing 15 to 20% savings just by effectively leveraging and using our platform in their buildings and in their respective VRF systems. And one thing I want to highlight here as well, this is difficult to quantify, but I think it might be the most important component, is when you're ahead of your customers, when you're ahead of the people on site, you have happier customers. Everything running great means that they'll see minimal impact when there is an issue. So using this tool is invaluable to retaining your customers, as well as promoting yourself and marketing yourself in your respective markets, and expanding out from here. So we are very grateful for your time and attention today. Again, my name is Ben Shipley. It was my pleasure to present to you. Kevin Ward also presented, and David Diaz-Perez is also on the webinar. We are going to open the doors now for anybody that might have any questions or thoughts, and we'll answer those. Please enter those into the window there, as you'll see on your console. You can ask those questions. We'll address them live, or David has potentially been answering some of those while we've been waiting. Thank you very much for your time and attention today.